Hello and Assalamu alaikum everyone. Welcome to my channel. In today's session we will explore the fundamentals of sprinkler hydraulic calculations. It is an essential aspect of fire protection design. If you are visiting for the first time, make sure to subscribe so you don't miss out on upcoming contents. I will be sharing valuable knowledge to help you excel in the field of fire protection design. So before starting the session, let me introduce myself. My name is Naveed Anjum and I have 19-year experience in fire safety as an advisor, consultant and trainer. I hold two key NFPA USA certifications, Certified Fire Protection Specialist and Certified Fire Inspector 1. I have also completed some online certification of NFPA like NFPA 13, NFPA 20 and NFPA 25. I am honored to be a appointed principal committee member of NFPA Lactic Generating Plants Committee since August 2023 and I was an international advanced member of NFPA also from the year 2020 to 2021. Currently, I serve as a director of the Fire Protection Association Pakistan. So let's move toward our main topic, hydraulic calculations, basics, fundamentals we will discuss in our session. Basically, hydraulic calculation are very important to ensure that flow rate in piping network will be enough to control fire effectively. In NFPA, the calculation procedures are established and verified by three basic elements of firefighting systems: water delivery requirement of sprinkler system, available water supply, the piping network system and its related friction loss. We will use a different formula like Hazen-Williams equations and we will discuss about in our next sessions like for friction losses. In today's session we will discuss about flow and pressure requirement for during hydraulic calculations. Hydraulic design of a sprinkler system must start with the thorough analysis of the commodity being protected. Basically, the National Fire Protection Association standard for installation of sprinkler system installation NFPA 13 classify commodities into three basic hazards categories: light hazards, ordinary hazards and extra hazards. Each classification has specific design requirement to ensure optimal fire protection tailored to the type of hazards. Some hazards like ordinary hazard and extra hazard occupancies both are further divided into two more categories. Ordinary hazard divided into ordinary hazard group 1 and group 2. Extra hazard divided into group 1 and group 2. So firstly you should know about the which type of hazard you are going to design the system. Once a hazard classification is chosen for non-occupancy, the water requirement may be established from NFPA 13, 2007, figure 11.2.3.1.2. We will discuss about this figure. I was discussing about this figure. NFPA 13 display 5 density area curves overline on graph 1, 2, 3, 4 and 5. Basically, the 5 curves correspond to the previously discussed hazard classification: light hazard, ordinary hazard 2, extra hazard and extra hazard group 2. These curves stipulate the required minimum densities and remote areas that establish minimum water requirement for sprinkler system. These curves basically stipulate the required minimum densities and remote area that establish minimum water requirement for sprinkler system. Like density, we will discuss about the density. The definition of density is the amount of water that must be delivered every minute for every square foot of floor space. The English unit of density is gallon per minute per square foot. For example, a light hazard could be designed for a density of 0.1. You can see that light hazard could be designed for the density of 0.1 GPM per square feet. It is basically density in the horizontal, and in vertical you can see it is area. This means that 0.1 gallon must discharge every minute for every square foot of floor space over a specified area. What is remote area? Basically the minimum area of floor space over which the density must discharge. Let's take an example. As an example, figure indicate that an acceptable design for ordinary hazard group 1 occupancy is 0.15, as we are discussing about ordinary hazard. Ordinary hazard 0.15 over 1500 square feet. 0.15 over 1500 square feet. There is area. So if we are getting area in square feet, so we can get density in GPM per square feet. If we are getting area in square meter, then density millimeter per minute. So here we are discussing about area 1500 square feet and density in GPM per square feet 0.15. So how can we calculate number of sprinkler in remote area? How much sprinkler will operate in case of emergency? So total number of sprinklers is equal to remote area divided by area covered by one sprinkler. For example, if remote area is 1500 square feet and area covered by one sprinkler, we are taking this is as an example, 130 square feet, then total number of or sprinklers is equal to 1500 divided by remote area divided by area covered by one sprinkler 130 and is equal to 11.538. Therefore, we shall consider 12 number of fire sprinklers which the water tank must provide for sprinkler to operate in case of fire. Calculating water flow and pressure of sprinkler. You can see this is the formula for flow. Sprinkler flow is equal to density and sprinkler coverage area multiply. If we will multiply density into sprinkler coverage area, then we will find the sprinkler flow. Here we know that our density is 0.15 and sprinkler coverage area is 130 square feet. For this, sprinkler flow will be 19.5 GPM. This is the answer of flow. No, we have to find the pressure also. So what is the meaning of 19.5 GPM? Means the end sprinkler must discharge 19.5 gallon every minute over the 130 square feet area. So if you know the required flow, like we know that this is the required flow of a sprinkler, you can use the K factor formula to calculate the required pressure P at the sprinkler. So what is the formula? Formula is P is equal to Q over K whole square. P is equal to pressure at the sprinkler, which is in PSI. Q is equal to flow rate, gallon per minute, which mentioned here, gallon per minute. K is discharge coefficient of sprinkler. Manufacturer can provide you a K factor of sprinkler. So mostly nominal K factor is 5.6. So in this example, we will take 5.6. We will consider 5.6 K factor. So if we put the values in the equation, is equal to 19.5, which is flow, here is mentioned flow, and divided by 5.6 K factor and whole square, the answer is 12.13 PSI. This is pressure requirement. What is minimum? Firstly, we should check three main points. Our answer is okay, yes or no. For this, we have to check 3 points. Firstly, what is the minimum required pressure by code? If we see what code is saying, what will be the minimum pressure? So as per code 27.2.4.11 of NFPA 13, minimum operating pressure. So minimum operating pressure of any sprinkler shall be 7 psi. So code is saying that minimum pressure is 7 psi. So what is minimum pressure required by manufacturer? We have to know about the manufacturer requirement. And third is minimum calculated pressure greater than minimized, means 12.13, which we find we have calculated is greater than 7 psi, or specification as provided by manufacturer. If it is okay, then yes, now you can move further next to your calculations. Basically these are the just basics of hydraulic calculation. You should know the basics. In our upcoming session we will discuss about more about it, complete hydraulic calculation and NFPA. as per NFPA standard installation of sprinkler system. Feel free to reach out with any question or for further collaboration. You can WhatsApp me anytime at my given number 0346999396 and you can also send me any query through email. Thank you so much for your time and attention. Thank you.